And I didn't have the YouTube on. There we go. Now it's on. That's too bad. All right. Here, let me do that. Yeah, in fact, since I blew it on that, let me do it real clean again one more time. Because it'd be good for you to see it too. So let me do it real clean. What was it? 1 over secant minus secant? Or do I have that backwards? Secant first, then? Okay, yeah, that's right. Okay. Secant, and then 1 over. Watch, it'll make a lot more sense the second time. It'll be good too. So here we go. Let's do it a second time. So what do you do with these guys? You got to get a common denominator, right? So therefore you put this over 1, multiply top and bottom by secant, right? And then that becomes secant squared over secant. Everybody good with that? I multiply top and bottom by secant minus 1 over secant. Good. Bring it over here. So then you make that secant squared minus 1 over secant because they have a common denominator. That's pretty much what you always do with fractions. Get a common denominator. Okay, then next we say, okay, now this, what do we do with that? We use that special rule, huh? We go over to our properties, which is right there, and we go, oh, that's kind of like this. Anytime you see tangent squared with a 1 or secant squared with a 1, you think about that property. And you go, okay, let me see. Tangent squared plus 1 is secant squared, says the property. You have that right in your 3x5 card. Move the 1 over. So, right, when things jump to the other side, they switch signs. So tangent squared is secant squared minus 1. So secant squared minus 1 can be replaced with tangent squared, huh? So then I go, okay, that top is just tangent squared, like that, right? That top just becomes tangent squared. And then what do you do at this point? Break into sines and cosines, which is, do you always do that? Not always, but often. Often when you have things like tangent and secant, you break it into sines and cosines. Yeah, that's usually a good way to go. Not always, but so I'll go, okay, so this is, let me get this out of the way here. This is sine squared over cosine squared all over 1 over cosine, right? Because secant is 1 over cosine. Tangent is tangent squared, sine squared over cosine squared. And then we grabbed the thing on the bottom. We flip it up because dividing is upside down multiplying. And we said sine squared over cosine squared times cosine over 1. And then we cross-canceled, huh? This cosine canceled one of these cosines. And we had sine squared over cosine. And this is where it's kind of really a weird step. You're thinking, well, isn't that good? What's wrong with that? Is good. I mean, that's good if they wanted that, but they happened to not ask me for that. Then I look at all these tangents, cotan. I went, oh, if I made something a tangent, maybe I'd see it. Can I make something a tangent? Yeah, if I just break this up, sine, cosine, and put the other sine off to the side, then this is tangent times sine. That's option A. Better? Look, not quite. See how already the second pass feels a little bit better? Do that on your own. On your own, blank piece of paper. No looking at notes. If you can't do it, it's okay. Look at your notes. Figure out what to do. But then say to yourself, I don't have it yet. Try it again the next day. Try it again an hour later. Blank piece of paper. No notes. Top to bottom. Once you can do it top to bottom, no notes, then you got it, right? And then you got to do that again a couple days before the test. So that's what it takes. Okay, so this one, cosecant times sine plus cosine. What's the I cut out the x's again. What's the natural thing to do? If we could, but what can I really do with sine and cosine? Nothing. They don't add. They're not like terms. Yeah, if I could add those, I would, but they don't have anything in common. Yeah, just go ahead and distribute. Right? Anything outside of parentheses just distributes in. So then we'll get cosecant times sine plus cosecant times cosine. Seem natural enough so far? Okay, and then what do you think about this part here? What do you think about cosecant times sine?
Is that the same as cotangent?
Remember? So what is that? It's 1. So let me show you why. Let's go back. Remember what cosecant is? 1 over sine, huh? So if you go back and you go, oh, so this is cosecant is 1 over sine times sine. These cancel. This is 1. Good so far? Now, okay, what else am I going to do? Well, at this point, you know what I do is I kind of keep one eye on the answers, one eye on my problem. That's what's hard about this, because, I mean, there's a million different things I could do. There's a lot of properties. There's not one way. It's just kind of what they decided they want you to do. So let me look back. What kind of answers do they want me? I'm looking going, oh, cotans. Look at all those. Look at the tans and the cotans. I'm thinking again about somehow getting there. So I'm thinking, okay, what could I do? What's cosecant? Again, it's 1 over sine, isn't it? Okay. So what? So that's, that's 1 over sine. That's just cosine. So what do you do when a fraction is multiplying a whole number or a whole expression? Well, these are multiplied, right? Not added. So just put a 1. Just multiply top with top and bottom with bottom. Yeah, like that. So I'll get cosine over sine, which is cotangent, isn't it? Cosine over sine is cotan. Now, hopefully they have that answer there. I'm hoping. Do they? 1 plus cotan. Yeah, B. Got it. So it's answer B. That okay? A little better? Not quite so bad on that one. That's probably a medium level one. Number 1 was a hard one. Questions to there? I want to try number 3. What do we get for number 3? Number 3 is sine over cosine plus cosine over sine. So hey, I'm just going to do this. Just S's and C's. Just to make it easier to work with. So what should you try on this one? Common denominator. Totally, because we're adding 2 fractions, huh? Let's keep going. So yeah, common denominator. So remember how to do common denominators? Multiply top and bottom of this one by S, top and that bottom of that one by C, so that both denominators are SC. Just give them what they're missing, right? Just give them what the other guy has. Right? That makes sense. See how both denominators are SC now? So that's going to be on the top, S squared over SC plus C squared over SC. Good so far? So, then we combine them into one fraction. Because now they have common denominator, huh? We can make them one fraction. That good with so far? Now, any thoughts at this point? Yeah. Yeah, remember this is 1. That's one of our properties right here. Yeah. Good. So this becomes 1 over SC, sine cosine, huh? Now, is that one of my answers? Look back at the, well, I got it here. No, none of them look exactly like that. Look back at number 3. You know, they're sines, and they're more tangents and stuff again.
Is there a way that we could do the inverse?
Oh, we won't need to do inverses on this thing. Okay. It doesn't get that hard. All right, so what could I do with 1 over SC to make it like some of those things that you're looking at? I mean, it's just creative. I know it's hard to get. You'll get used to it over time. You could say, look, that's 1 over S times 1 over C. You could separate them, right? That's the same thing, right? And why am I doing that? What is 1 over sine? Remember, this is sine, really. This is cosecant. And what is 1 over cosine? Secant. There it is. Answer D. See that little step I did at the end? I just said, look, I have a sine and cosine on the bottom. 1 over sine, 1 over cosine. That means cosecant, secant. That's answer D. Is that okay? So this is especially one of these sections where, you've ever had the experience, you watch the teacher do it in class, the math teacher, science teacher, whatever, and it makes sense. You're like, oh yeah, I followed all that. And then you try to do your own homework, you're like, wait a minute, what did that teacher do? You'll especially experience that, because I kind of know where I'm going, so that's what you need to get used to. You really, 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 don't say to yourself after we're done, hey, I know this stuff because I copied them down from class. Now you're just lying to yourself. Take out a blank piece of paper, try it on your own. It's a whole different world. You need to get used to that. So make sure you do that for yourself. Don't fool yourself. All right, so number 4 is sine. I'm just going to do the S and C thing again. Sine plus cosine squared over 1 plus 2 sine cosine. Okay, so this is a mess. So what can we do with that top? Can we just write 2 of those parentheses and FOIL it? That's a great idea. You know what I mean? So the top, that's going to be S plus C, S plus C. I'll just leave the bottom as it is for now. And then just go ahead and FOIL out the top. Can you just FOIL it? So then on the top, we FOIL out, what do we get? S squared plus SC plus SC plus C squared. Let's leave the bottom the same. How are we doing? Are we okay to there? And now can we combine like terms on the top? Just kind of like algebra, it's x's and y's. Just combine like terms. It's 1 SC and 1 SC makes 2 SC on the top up there. How we doing? We good to there? What's that? Yeah, can we cancel? Well, no, you can't with pluses. Yeah, okay, so that's an important rule you need to know. Pluses and minuses glue things together. You can't cancel unless they match completely. But what can we do? Kevin?
Take the S squared and C squared and make it 1.
Yeah, good eye. Do you see that? You always want to be looking for these guys. Whenever you have S squared plus C squared, remember that rule? S squared plus C squared is 1. Remember back here the property? Wherever it is there? That's super important property, maybe the most important. It comes up a lot. Sine squared plus cosine squared is 1. So yeah, so whenever you see those guys, you can say, well, they together make 1. And now, yes, for sure we can cancel, because now they're just like exactly the same, huh? So that's just 1. All of that is 1. That means this whole mess is a fancy way to say 1. Like that. Is that good? And that's whatever answer that is. A? That answer A? On the thing there. All right. Questions on that one? Getting a little better. So that was not too bad. All right, let's try number 5. Number 5 is 2 tangent minus 1 plus tangent squared. All right, so you probably know you should FOIL out those parentheses again, huh? Right, 2 of those parentheses, FOIL them out. But watch out, there's a negative in front of that parenthesis. So when you're all done with the FOIL, that negative will have to go through at the very end and change all those signs, huh? You know what I mean? So just leave the minus here and just FOIL out. Well, it's 1 plus tangent, 1 plus tangent, like that, right? And so that would. So now just go ahead and FOIL all that out. First to both, second to both. Just FOIL, multiply that out. See what you get. So FOIL this here. 1 plus tangent plus tangent plus tangent squared. Is that good to there? Then gather some like terms. And this becomes tangent plus tangent. That's 1 tangent and 1 tangent. That's 2 tangent, right? Just like terms there. Good. Not making sense there. Just like terms. And now let that minus sign go ahead and distribute all the way through there. So the minus sign will go boom, boom, boom. Like that. We'll get 2 tangent minus 1 minus 2 tangent minus tangent squared. This good so far. I'm doing algebra, right? I FOILed out and distributed. That's really foiling and distributing. It's kind of good practice, kind of hones your algebra skills. And now what can I do?
Well, the 2 tangent and 2 tangent can cancel each other out.
Perfect. Those are gone, huh?
Then I have the negative 1 minus 2.
Well, the tangent, yeah, you got me doing 2 there. Yeah, I know what you mean. It's tangent squared. Yeah. Yeah, okay. What do you think, Kevin?
Can you pull out negative and then use the property of tangent squared plus 1 equals secant squared?
Well done. Exactly. Yeah. So keeping an eye. What Kevin's doing is keeping an eye, I assume. Keeping an eye. Because what we have right now is good. I mean, they could have made that their final answer. I mean, that's a fine thing. But they didn't. If you look back at the thing, number 5, look at the answers they have. They have a 1. They have a 1 minus sign. What's that? A 0 and a minus secant squared. Secant squared. Remember the property? Secant squared is 1 plus tangent squared. Think, oh, if I can get a 1 plus tangent squared, I got something kind of like that. That'll be secant squared. Go, oh yeah, just take out the minus again. Right, just factor out the minus. Right? Because that minus could distribute back in, right? It's the same thing. You know? And then, yeah, just like Kevin was saying, secant squared right here is, 1 plus tangent squared is secant squared, isn't it? There's the answer. Is that D? Yeah, D.
Couldn't you have just, instead of distributing the negative immediately, done secant squared within the parentheses?
I could have. That might have been a better way to go, Presley, yeah. Right here, this 1 plus tangent squared, I could have just made those 2 into secant squared right away, and then just subtracted off that 2 tangent. Would have been a little quicker. Yeah, that's right. Yeah, so there's many ways to do these, and I'm not always doing it the most efficient way. It's just what I happen to see at the moment. So is that good? Questions on that one? All right, so we'll keep going. Number 6. Tangent times cotan minus cosecant. So yeah, so when I take that, when I take that tangent, I go boom, boom, and I go tangent times cotan minus tangent times cosine. Like that, right? I distribute to both of those. Like that. Now, what is tangent times cotan? That's 1. That's 1. Right? Because they're upside down of each other, right? Minus. Okay. Yeah, now what should I do at this point?
Make it cosine over sine over cosine and cosine over 1.
Yeah. This guy is sine over cosine. Like that, right? and then, boom, because over 1, yeah. So it's 1 minus sine, and that answer's there, huh? It's D again. Is that okay? I called it 1 step, but I really did like 3 steps. But depending on how you write it. Is that okay? Questions on that? All right, I'll keep moving. How many of these we got? Oh, that's just, I was saying 16. 18. Okay. 18 of them. Let's try number 7. So sine squared plus sine squared times cotan squared. Okay. Yeah, let me help you with this one. There's just a lot of things you could do. This one's a new maneuver. But what we're going to do on this one, it's kind of like looking at, let me help you. X squared plus x squared times y squared. What would you do if you had that? What's one thing? There's a million things you could do. What are some different thoughts you have? What you would do? What if somebody said, hey, do something with this? What's one thing you could do? Is there anything you could do with parentheses? Do you remember factoring?
X plus 1.
Remember, you could take out what's in common. They both have an x squared. Take it out, leaves 1 plus y squared. You remember like factoring, which is just reverse multiplying? You know what I mean? Right, because that can multiply there and go back to x squared, multiply there, go back to that, huh? Right? So you just take out what's in common. So as you look at these two, take out what's in common. What do they both have? Excuse me. Yeah. Excuse me again. A sine squared. Okay. And then go ahead and put what that leaves on the inside. And then, yeah, go ahead and do that. And then look at that inside once you have it. And look back at your properties. So 1 plus cotan squared, we good to there so far, right? Because that sine squared could go boom and multiply both those. Like that. And then, yeah, look back at your properties. Look for this. If you go back there. Oops, there it is. 1 plus cotan squared is cosecant squared. Yeah, so you would want to kind of be looking for those things like 1 plus tangent squared or 1 plus cosecant squared or cotan squared, and you know they're in our property list. So then we go, okay, so this is sine squared, and this is cosecant squared, right? Cosecant squared, okay. Now what? Yeah, remember what cosecant is? It's 1 over sine. Yeah, this is a big 1. Do you see it? I'll take it slower. But if you can just see it, you can just write 1 right now. See, that's 1 over sine squared, isn't it? Cosecant squared is upside down of sine. So then they just cancel. 1. Answer A. Again, this is a big fancy way to say 1. So that's a little different. We didn't factor on any of the other ones. It's kind of weird. Like, where'd that come from all of a sudden? I know. It's weird. It's different.
Can I see the list of properties?
Yeah, maybe I'll write them up on the board in a second. Yeah. So, all right, let's try. Any other questions on that one? We good? Yeah.
Could you have said that cotangent squared is cosine squared over sine squared?
Yeah, nice. Oh, I like what you're doing. Yeah, good, Caesar. Caesar's got a nice way to do this one. Nicer than what I did. Yeah. Look what Caesar said. Caesar's saying, okay, look, let me go back to the beginning here. He's saying, look, take that cotan, and what is cotan? Yeah, this is better than my little factoring trick. Yeah, I like this. It's It's cosine squared over sine squared, right? That's what he's noticing. That's what he said. Cosine squared over sine squared. That's what cotangent is, right? And then, boom. Right? Because it's over 1. So what does that give you? Well, then that's sine squared plus cosine squared. This is all that's left here, right? The sines are gone. And what sine squared plus cosine squared?
1.
Easier, huh? No factoring needed. Nice, thanks. Yeah, that's what I mean. These are just creative. I don't always have the best way. I just see some things. And yeah, good. So you might see better ways as you're going back over these too. Good observation. All right. Let's go to number 8. So let's try sine squared plus tangent squared plus cosine squared. Anybody have a good observation? Presley.
You can make sine squared plus cosine squared 1.
Exactly. Whenever you see those guys together are 1, aren't they? And so then we bring that down, and it becomes 1 plus tangent squared, which is one of our properties, secant squared. Yes. Is that there? Nice. That's our favorite one so far. Yeah. Good. Is that good? So some are just a lot easier than others. See, number 1's still almost the hardest one we've done. All right, so go on to number 9. If you got that down okay, move on to number 9. Number 9 says cosecant times cotangent over secant. Yeah. Probably, I can just tell you my thought off the top of my head. I would probably break those into sines and cosines. I'd probably break all those into sines and cosines. Because everything's made out of sines and cosines, aren't they? All the other trig functions are made, right? Tangent is sine over cosine, and secant's 1 over cosine, cosecant's 1 over sine. They're all made out of sines and cosines. All of trig is really sine and cosine, isn't it? So go ahead and break all those into sines and cosines. That way you get things to cancel, and they'll interact with each other. That's kind of what you want to happen. So break them down to sines and cosines. See if something nice happens. Okay, so cosecant, that's 1 over sine. Cotangent is cosine over sine. And secant is 1 over cosine. Good to there so far? So what do we always do when we have a fraction on the bottom of a fraction like that? Yeah, grab it and flip it up because dividing is upside down multiplying. So then we'll get 1 over sine, cosine over sine, times cosine over 1. We get to there. So, I don't know. Oh yeah, we're almost there. So, anybody see anything? What can we do? Good. Exactly. 2 cosines on the top, 2 sines on the bottom, cosine squared over sine squared. And what is cosine over sine? Cotan. Squared. Yep. And there it is. Letter A. Have we had any C's yet?
No.
Good there. Questions? All right, let's go on to number 10. Oh, 10's a nice one. Tangent times cotangent. That's just 1, isn't it? Because it's upside down, right? Cotangent's upside down. That's just 1. Answer B. That was nice. All right. On to number 11. So, let's see, we got tangent plus 1, tangent plus 1, minus secant squared over tangent. Yeah, that's like a mess. All right, so foil that out on the top. So boom, boom. Tangent squared plus tangent, boom, boom. Plus tangent plus 1. Minus secant squared all over tangent. Good so far. Just foil that out. And then kind of gather some like terms here. Tangent squared. 1 tangent and 1 tangent is 2 tangent. Good to there. Thoughts, Damon?
We can get rid of the tan squared and plus 1 because secant is tan squared plus 1.
Yeah, well said, well said. So everybody see what Damon's noticing there? That the property 1 plus tangent squared is secant squared, right? 1 plus tan squared is secant. It's one of our properties. So this and this together is secant squared, huh?
Right.
Minus the other secant squared, they all just vanish. Is that too quick? I can write it a little slower. So so in other words, it's gonna, those two become secant squared. Let me put everything else in there. Plus 2 tan minus secant squared over tangent. And then, yeah, these guys cancel, don't they? That is. Everybody seeing that? So the 1 plus tan squared together becomes secant squared. Like that. They together become that. And then we just get 2 tangent over tangent, cancel 2. Which is hopefully one of those answers there. It is B. Still no C. There we go. On we go. Numbered, 12 looks rough. Common denominator for sure on number 12. Just use S and C. When the whole problem is just sines and cosines, that's when I just use S and C. If there's other things mixed in there, then I can't do that because the C might be cosecant or something like that. So for number 12, you've got, so I would just write C minus S, cosine minus sine over cosine, plus sine minus cosine over sine. So I would for sure just do common denominator. You want to make the two denominators the same when you're adding two fractions. So get a common denominator. So I would multiply top. Remember, you multiply by the other denominator, right? That way you make them both have the same stuff. And then multiply this one by C. See, now they both have SC. I just multiply by the other denominators. Now they both have the same stuff. And really this distributes, doesn't it? So now you can combine them into one big fraction. Combine them into one big fraction. Like that, because their denominators match. That's why we get common denominators, so we can make it one big fraction. So what do you think? Anything we can do there?
Can you get the sine squared and cosine squared to equal 1?
Mm-hmm, mm-hmm. And we can combine the S's and the C's, right? I mean, one SC and one SC, combine like terms, two SC. So I'll say, okay, that's 2, any order here, doesn't matter, minus sine squared minus cosine squared over the SC. Yeah, and then, yeah, exactly how do we handle the,
We'd have to pull out a negative.
pull out a negative, exactly. Does everybody see that? If I factor out that negative, it would make that plus like that, huh? See how that's the same thing? Is that too quick? Let me put it back the way it was, and I'll do it more slowly. So minus.
The whole thing by negative 1, right?
Well, I'm gonna, yeah, I'll bring this up and I'll just factor out a negative 1. Yeah, and that it effectively does. You can see it's right. Just imagine if that was to go back in and go back in. See how it would go back to be the same thing?
Yeah.
So it's correct. So factoring is just reverse multiplying. So to check it, just remultiply. That's all I'm saying. That's all factoring is unmultiplying something. So you just put that in front. That's the same. If that minus 1 multiplied back in, it would be the same. So I haven't really changed anything. So then what is this? Or let me bring it over here. I think we might have a couple more steps. I'm not sure. I haven't even really looked at the answers yet. So 2SC, and then what? Minus S squared plus minus 1 if you want, over SC. So what is that sine squared plus cosine squared?
1.
That's 1, right? We have that property. Sine squared plus cosine squared is 1. So then that does become 2 sine cosine minus 1 over sine cosine. Okay. It's still not there. I can see what to do now, but I'll show you. But we good to there? Everybody good to there so far? I'm going to take that to a fresh screen, if you're okay. So we have just the first double screener here over SC. Okay, yeah, as I'm looking at the answers on number 12, go back here to the answers. So I'm looking at the answers. Oh, I didn't even put the answers up for number 12. So as you look at the answers, yeah. I don't know how to tell you. There's just another new thing we're going to do here. I'm going to break up over a common denominator. Yeah. You know what? I better say more than that. First off, can't I just cancel those? No, actually, you can't. Not as they stand. Yeah. Have I talked about Costco glue stuff at all in here? I know you haven't before, and I did in that class. Did we talk about that at all? Pluses and minuses glue things together, make them a package deal, kind of like Costco. That's always my analogy. You know those big warehouse stores, Costco, Sam's Club. You shop, everything's glued together, plastic together. You can't buy just one milk. If you go to buy one milk, it's plastic to another one. My wife shops at Costco because we have 5 kids. You buy in bulk. That's you get a little cheaper deal. You buy in bulk. So if you grab one thing, there's never just one at those warehouse stores. They're always in groups. Well, that's what pluses and minuses do in algebra. And you're going to want to know that, especially if you go to pre-calc calc, if you go up the line. It'll come up more and more. Pluses and minuses glue things together, which means they're a package deal. So if you want to cancel anything, you cancel the whole thing, not just part of it. Just like you can't take your scissors to Costco and just cut the plastic and say, thanks, I just want one milk. They won't let you do that. It's packaged. You buy both milks or none. Well, that's what this is. You either cancel this whole thing or nothing because they're glued together. Pluses and minuses do that. If that was, my point is, if that was times, I could totally just buy the SE. That'd just be shopping at Save Mart. If they're multiplied, you can cancel just one. No problem. But pluses and minuses are what glue things together. In fact, they're what make algebra hard. It's all the plus minus stuff. Basically, pluses and minuses wreck algebra. They make all the hard rules. Nothing nice or quick or shortcut ever works with pluses and minuses. It always works with times. If that was times, yeah, just cancel that out. No problem, we're done. But if it's plus or minus, you can't do it. It's a really important rule to know. Pluses and minuses glue things together. Make it a package deal. What was this? 2SC minus 1 over SC. So we cannot, that top is a glued package. I buy the whole package or none of it. I can't buy part. So well, then what do? Well, then that's what leads me to think about this trick. I think, well, I'm just going to separate them over a common denominator. So that's just separating them. They both have the same denominator, right? Why would you want to do that? Well, because now you can cancel these guys. Because these are just all times, aren't they? See how that allows me to cancel there? That makes sense? Because it's just multiplied there. So what? So that's 2 minus 1 over SC. It's one more, we're just one step away. See how I had to do that in order to be able to cancel. That's a really important algebra rule as you're going forward to higher math. You want to make sure you really know that. Plus and minuses glue things together, package deal. So when I separate them, common denominator, then I can cancel because then there's just multiply. There's no pluses or minuses between those guys anyway. So I can cancel. Okay, so what? Where am I at? Well, look down at your answers. See how there's a 2 on A and D? I'm looking at A and D. See how they look really, really like my answers? What can I do? What is this 1 over sine, 1 over cosine thing? That's cosecant, secant. Remember? 1 over sine is cosecant. 1 over cosine is secant. It doesn't matter. You can switch these. It doesn't matter. That's answer A, right? Answer A. Everybody okay with that last step? And too quick. This is 1 over sine and 1 over cosine. So that becomes cosecant, secant. That's answer A. That's a hard one. A lot of tricks. Separating over a common denominator. We don't usually do that. The whole Costco glue rule. All right, lot to that one. Practice that one. Questions before I move on? I got 20 minutes. See if I can finish these. It'd be nice to have them all here. We won't have to go out to YouTube. Let's see, cosine squared minus sine squared. So I write out cosine and sine on this one instead of just going C and S because there's also a tangent. So when there's something else involved, then I write them out instead of just C and S like I did in the last problem because that's all there was sine and cosine on the last problem. But this one has other stuff. All right, so number 13. I don't know. It's like a lot of our properties, but not quite. I don't know. I really don't. I can't think of it off the top of my head. So we could. There's a lot of things. We could break into sines and cosines, maybe. I don't think so. We could do something with that numerator. Cosine is 1 minus sine, so that'd be 1 minus 2 sine squared. What would that do for us? The bottom 1 minus tangent squared.
Could we multiply the whole thing by the denominator?
Yeah, because that would be tangent is sine over cosine.
Right. Yeah, I just don't think that would make anything nice happen. We just get uglier. Sometimes you go in a certain direction, it just gets worse.
But it would.
How about we move on, and because I don't want to waste your time, and I'll do it real quick on my own. I'll try some crazy stuff which might waste all of your time, and then I'll find the good way, and then I'll come back here in a minute and do it for you. So let's go on to 14. 13's too hard for me to do without some careful thought. So try that one. Try 14. Yeah, I need to give you a hint on 14 also. That one needs to be factored. That's like looking at x to the fourth minus y to the fourth. Do you remember how to factor that kind of thing? How do you factor that kind of thing? Do you remember factoring a little bit? x squared times x squared will go back to x to the fourth. Remember that? And y squared times y squared will go back to y to the fourth. And how do you get negative y to the fourth?
One positive,
1 positive, 1
1 negative.
negative, huh? Because positive times negative, positive y squared times negative y squared will make negative y to the fourth. Do you remember that? It's called difference of squares from algebra. I call it double double. I like In-N-Out Burger. Yeah, double double. It's like, and it kind of fits what it is. It's x squared, y squared, right? It's something twice, isn't it? It's a double double. So when you see double double, you can break it up into separate, 1 plus, 1 minus to make minus. Now, you can do it again, sort of, with half of it, not with the other half. So they're really pushing your algebra knowledge of factoring here. It's a pretty hard fact. I always have to remind my pre-calc and my calc students about this. So you're doing good if you already remember this at this level. Yeah, Kevin.
On this specific problem, can we take the x squared plus y squared and just change it to 1?
Yeah, that's what we're going to do in a minute. You're totally right. Yeah, and yeah. So let's do. Yeah, I like what you're saying, Kevin. So go on over, do that with the sines and cosines. Well, actually, let me mention one more part. This part will break down again into x plus y, x minus y, and then this part's going to do what Kevin's saying. It's going to be 1 because it's sine squared plus cosine squared. All right. So try all that over here now. So I just did it with x's and y's. Try it over there with sines and cosines. See what you can do. I'll fiddle around with number 13. Here. So let's see it. So this is going to be sine squared minus cosine squared sine. Well, I did the plus first and the minus. Doesn't matter what order. Good to there. And then this is just 1, huh? We got that property. This guy will break into 2 things and be sine plus cosine, sine minus cosine. And is that just our answer? Oh, no, that would be too easy, I guess, huh? So, oh, no, they did a trick. Did they? Yeah. Okay, let's don't do this. I mean, that first step's good. And that second step is true, it's just not where they went. So this is 1, this is still true. And let me just leave sine squared minus cosine squared as it is. Even though it is sine minus cosine, sine plus cosine, I'm looking at the answers. They didn't go there. Here's what they did. So first off, this is just sine squared minus cosine squared, because 1 times it is just itself. Okay, now, bless you. Now, I'm looking at the answers on number 14, and I'm seeing that notice they're all sine or all cosine. So they substitute. This is where you're going to see one of the first times where they'll make a substitution step. What do I mean? They're going to take that basic property, sine squared plus cosine squared is 1, that probably the most important property that we use the most, and they're going to say, look, if I just grab this guy and jump him to the other side, what happens when things jump to the other side of the equal sign? Changes signs. Yeah, sine squared is 1 minus cosine squared, like that. Then so that means wherever I see sine squared, I'm free to replace it with 1 minus cosine squared. It's just 1 step away from the original thing. So that means come over here, right there. Sine squared becomes 1 minus cosine squared minus the other cosine squared. Did you see that trick? Am I going too quick there? Let me back up a little bit. So I got down to sine squared minus cosine squared. I looked over here and said, well, I'm going to take the Pythagorean identity. Sine squared plus cosine squared is 1. Solve for sine squared. Plug it in over here for sine squared. And now, what is 1 minus cosine squared minus cosine squared? It's minus 2 cosine squared. That's there, isn't it? Answer A. Good there? Little trickery. Why didn't they do the other thing? They just did it. I mean, there's just a million things they could do. They just happened to go that way. Is that good? I'm ready to go back to 13. Let's go back to 13. I think some of you said break it into sines and cosines. That is the best way to go. It turns out I said no at the time. I was wrong. So here's what we should do. We should do cosine squared minus sine squared. over, well, here, let me bring it down. Give a little more. It'll only be a couple steps. It's not bad. Cosine squared minus sine squared over, well, now what's tangent? Remember what tangent is? Sine over cosine, right? So this is sine squared over cosine squared, like that. We good to there so far? Okay, now, I don't know if you're familiar with this kind of step we're about to take. One thing you can do when you have, this is called a complex fractions over fractions. I know most of the time you've seen me grab it on the bottom and flip it up kind of thing. You can't do that with a minus. There's the Costco problem again. Pluses and minuses wreck all the nice rules, including this one. That whole flip it up thing, not with a plus or minus, because that one's going to say, I'm here too. We're glued. We're a package deal. Don't be grabbing just that guy and flipping it. And you can't do it. If that was times, if this right here was times, I would totally do that. I would just grab it and flip it. No big deal at all. If you look back, all the times we've done that, there's not been pluses or minuses on the bottom. So because of that minus, I can't just grab that guy and flip him. They're glued together. So what do you do then? Well, then you put your eye on this guy. He's the extra denominator, you know, which is kind of making the thing messy. And you multiply top and bottom by him. So you go up to the top and you go c squared. You go to the bottom and you go c squared. I'm just going to multiply both these by c squared. I'm going to distribute it on the bottom. Why did I distribute it on the bottom? Because I want this to happen. So everybody see what I'm doing? I'm just multiplying top and bottom by c squared. That's what we do when you have a fraction on the bottom of a fraction with a plus or minus and they're glued, is you multiply by the extra denominator, top and bottom, c squared. So that's something you want to get used to if you're going on to pre-calc and calc. They do that a lot. So, all right, so what? So this leaves me with, we're just one step away actually, c squared times c squared minus s squared over, now what's on the bottom? C squared times 1, just c squared minus, these have canceled, so it's just s squared and there it goes. And that's okay to do. I'm buying the whole package. Costco will sell you the whole package. That's fine. C squared. And that's answer A on number 13. So a little trickery there. Something we're probably not totally used to. Shall we keep going? Got about 8 minutes left. So we're on to 15. Getting close. Cosecant plus 1. Times cosecant minus 1. Whoops. Over cotan squared.
This one's another substitution, I think.
Yeah. Yep. So you want to FOIL out that top. Can you FOIL the top out there? How about in the interest of time, I go kind of quick, see if I can get through them for you. Just FOIL out that top. You'll get cosecant squared minus cosecant, boom, boom, plus cosecant minus 1, all over cotan squared. And then these cancel, right? And you get cosecant squared minus 1 over cotan squared. Now, what is cosecant squared minus 1? Well, if you look back at the property, the identity, I mean, that says, what is it, 1 plus cotan squared is cosecant squared? You think, yeah, but I have cosecant squared. Am I racing ahead of you? I'm looking at what am I going to do with cosecant squared minus 1? Well, remember this property. If you grab the 1 here and you jump it to the other side, then you'll get cotan squared is cosecant squared minus 1, huh?
Right.
So that means this and this I could plug in for all of this cotangent squared. The bottom is also cotangent squared. This is 1. Number 15. C, there's our first C answer. Is that good? On to 16. That's okay. It'll be on YouTube if that was too quick. 16. We have cotan squared of 2x plus cosine squared of 2x plus sine squared of 2x. It's kind of weird they're putting a 2x in there, but whatever. But you don't have to do anything with it. It's just there, and it's there in the answer. Don't let it bug you, in other words. It's just there. Same as regular x. Does nothing. Makes no difference. All right, so these two, what can I do with sine squared plus cosine squared?
1.
That's a 1, isn't it? Okay, next, what do you do with 1 plus cotangent squared? This is all cosecant squared. And I think we're done, right? There it is, B. Two more. You're okay. So number 17, ready to move on. 17 says 1 minus sine. I'm just going to use S's and C's since there's nothing else in the problem. 1 minus sine over cosine. Yeah, just any ideas?
Break it into 2 parts.
Break it over the common denominator, right? They just make it 2 separate like that, right? Because that's common denominator, right? They both have the c, so you can just make it 2 separate fractions having that same denominator. We did that maneuver a few problems ago. And then, what is 1 over cosine? 1 over cosine is secant?
No.
Secant. And what's sine over cosine? Tangent. Hopefully that's there. Secant minus tangent. Answer C again. Finally, number 18. Number 18 says cosecant squared times secant. When I see cosecant squared, I'm thinking of the property we have. 1 plus cotan squared is cosecant squared. So I'm going to replace this cosecant squared with 1 plus cotan squared. All right, good to there. And then distribute the secant. Just multiply it to both. Secant times 1 is secant plus cotangent squared times secant. Right? We're close. I'm going to need a little more room, but I can go to a fresh screen. Or maybe I can finish it right here. Okay. So basically, I'm looking at the answers on 18. It's looking really close to B and D. Look at B and D. See, that's almost the same as them. What can I do to change it? Well, I'm going to leave this secant because B and D both have a secant in the front. Just leave that. See how I'm kind of eyeing the answers and kind of moving towards it? Cotan squared, I'm going to break that into sines and cosines because I need them to interact somehow. Whenever I need them to interact, I break them down to sines and cosines. So that's going to be cosine squared over sine squared. And what is secant? 1 over cosine. Right? And then you can cancel this cosine with one of those. And I get secant plus cosine. I'm running out of room here. Running out of room, running out of time. Bring it up here. This is secant plus, separate this, secant plus cosine over sine squared. And then I can separate that. Do you see it? This is going to be secant plus cosine over sine times 1 over sine. See how I separated those? Right, the two signs on the bottom. Why am I doing that? I'm eyeballing the answer. Secant plus, and then what is cosine over sine? Cotan, right? Cosine over sine is cotan. And what is 1 over sine? Cosecant. That answer's there, isn't it? Secant plus, they just have it the other order. Yep. Answer B. All right.